I'm going to go through a mock test in which I have to resolve forces into parallel and perpendicular. And then from there, I'm going to calculate the acceleration using different formulas. In this case, I've got an object which is experiencing two different forces. For example, 25 Newton, let's say, to the right, and then 65 Newton to the left. And these forces are at an angle to the horizontal. So for question 1, resolve the forces parallel and perpendicular to the ground. So what I have to do is I need to draw two lines which is perpendicular and parallel. Now 25 Newton, which is 20 degrees to the horizontal, it can be divided into two components, into a component which is the horizontal and the component which is to the vertical. The horizontal component of the force will be, since we're going towards the angle, so therefore it's going to be 25 cos 20. 25 Newton multiplied by cos 20. And I've got 65 Newton here. This can be divided into parallel and perpendicular, or let's say horizontal and vertical components. Excuse my drawing there. Okay. So 65 Newton can be divided into horizontal component and to parallel component. So the horizontal component will always be, you do 65 times by cos 50, cos of the angle. In here I had 25, so the horizontal component would have been 25 times by cos 20. In here 65, 65 multiplied by cos 50. The parallel component would be 25 times by sine 20. And for this force, the parallel component would be 65 times by cos, sorry, my mistakes, sine 50. Okay, so question 1 done. Resolve the forces parallel and perpendicular to the ground. So these are perpendicular to the ground and they're parallel. So now this is not my final answer. I need to write down the answer. So if I plug in my calculator 25 cos 20, that would be 23.5 Newton. And then in here 65 cos 50, that will be 41.8 Newton. So 1 decimal place. Okay, so I'm going to do the same thing for the parallel components. Okay, so 25 sine 20, that would be 8.6 Newton. And then in here, that should be about 41.8. Yeah, so that is my answer. Okay. So, question 1 done. The next thing says, calculate the magnitude and direction of the resultant force. So the magnitude and direction of the resultant force will be into horizontal and vertical. So now I've got a 10 Newton force in here. So 10 Newton will be acting vertically downward. So therefore, I can divide this into perpendicular, and also into vertical and horizontal components. So I'll use a different color for that. Okay, now, so number 2. So I'll do number 2 in here. Calculate the magnitude and direction of the resultant force. Now, let me do the horizontal first. The horizontal would be, so all I've got to do is subtract the bigger force from the smaller force. So that'd be 41.8, take away 23.5. And that's 18.3 Newton. And the direction would be, it will always be to the direction of the bigger force. So therefore, it will be in this way. Okay, so done. And the third one, calculate the horizontal acceleration. Sorry, I've not finished the third one, so it still needs to do the vertical component. So, okay, so the vertical component would be, now we need to add these two forces because they're acting in the same direction. They're both going up. Take away 10 Newton, which is going vertically downward. So therefore, it will be, so vertical be 41.8 plus 8.6, and I need to subtract that from 10. 40.4 Newton. Okay, so that would be the, so 2 then. Now, calculate, number 3, calculate the horizontal acceleration. Now, if I want to do the horizontal acceleration, so I'm going to use this formula. Acceleration would be resultant force over mass. I've got the resultant force for the horizontal, but I need to work out the mass. So since I've got a 10 Newton force, so mass is going to be, so if I use this formula, W equal to mg, therefore m would be equal to W over g. If I use that formula, then I should be able to get the mass. Mass should be 10 divided by 9.81. Which is about 1.02 kilogram. Okay, so I've calculated the mass. So now I can move on to number 3. So acceleration would be, so calculate the horizontal acceleration. Horizontal acceleration would be horizontal force divided by mass. So the horizontal resultant force is 18.3, that divided by 1.02. About 17.94. And I can do the same thing for the vertical acceleration. So for the vertical acceleration, I'm going to use the vertical component of force. So for vertical acceleration, acceleration will be equal to the vertical force, which is 40.4, divided by the mass, which is 1.02 kilogram. $39.6. 39.6. Now I'm going to give its units, so meter per second square, and then I'm going to do the same thing for that one, so it'll be meter per second square.